Mhm.
Is there a way to look at the questions that we got from the exam?
Yeah, you will. So after Wednesday, you will be able to actually check your midterm one. Okay, and if you have any questions, you bring your question and come to me. We can discuss. Mhm. So how do you guys feel so far? The semester is actually, we've been doing this for a month, maybe a month now. Everybody still feel energetic, or you kind of like feel like, oh my gosh, it's the what is right here. Okay, so if you feel like you have some difficulty, okay, and you need someone to actually kind of put down some of your pressures, okay, you know, my door is always open. Don't push yourself too hard. Yeah, like it. Thanks, push this. Let's say you get to entry on all of your homework and all your. So you test average around 77. So I can take you. So if it comes crumbling down on me, it's like. Right, so let's get started. Okay, first I want to thank you for coming today. You know, based on my past experience, today, which is a day during the midterms, other days I'm going to have the least amount of students present in the class. Okay, so that's why this lecture will be, we are going to go slow today. Okay, and then I know you guys are busy with preparing your midterm one, so I guess many of you won't have the time to actually go through this YouTube video yet, right? So what we're going to do is actually we're going to introduce the concept slowly, and then only go through 2 key ideas for chapter 13. Okay, so hopefully by the end of the day, when you walk out the door, you can actually get the most important concept for chapter 13. Okay, we'll cover all the concepts you need for chapter 13 homework and quiz today. Okay, so then we'll go do more like more interesting things on Thursday and next week. Okay. All right, so before we get started, let's address some of your question, okay? But before you ask any questions, I want to emphasize that I know midterm 1 is here, okay? I know everybody is under a big pressure, okay? But please stay positive, okay? If you feel like, okay, you did great for your midterm 1, wonderful. Okay, I do see a lot of students score very high. Even now, okay, we have roughly like 40 students who already finished your midterm 1, right? And then there's actually a good amount of students who actually score almost perfectly. Okay, so I'm happy for you guys. I also see some of the students did not do really well. Okay, and then for those students, you feel like you did not actually achieve the grade that you want. Okay, I will strongly encourage you to print out your midterm, okay? And then you should actually connect with me. We can go through the things that you did not done correctly, okay? And then we can discuss the plan for you to actually prepare for the rest of the semester, okay? But do stay positive, okay? Don't do something silly, please, okay? I think that's actually the first point I want to emphasize, okay? If your test is tomorrow, so you're lucky, right? You actually do the test at the very last day, right? So good luck with your exams. Okay, if you have any questions, okay, email me your question. Okay, I'll try to answer it. Okay. Okay, so I'm very glad that the review is actually helpful. Okay, and then we're going to continue to do these things for the rest of the semester. Okay. Next week is actually an important week because next week you are going to earn your 1 extra bonus point next week. Okay. How are we going to earn that? We do the midterm survey. Okay, so the survey will actually a few questions that you can just check out the numbers. But at the very bottom of the survey, you're going to encounter a few you need to actually write something. Okay, so the question will typically like, okay, what are the things that you like the most? What are the things that you hate the most? What are the things that you want me to actually have for the rest of the semester? Okay, so I need, yes. Yeah, just this class, nothing else. Okay, just this class. Yeah, there'll be actually another one at the end of the year. You get your another extra point by doing the evaluation. Okay. So I think this is actually an effective way that I can actually understand what you want. Then I can actually really work for it. Okay. Like I say, my role is very simple for this class. I'm just a helper, nothing else, just a helper. Okay. And I know everybody have this different expectation for the grade that you want for this class. Totally respect that. Okay. I don't treat the student with A versus with C. If let's actually expect a score, okay, I don't treat you differently, okay? I respect everybody, okay? So, but do your best, okay? That's actually a way that you can show you're actually responsible for your own future, okay? So please do that. All right, so the next one is, can I do all the steps for the problems, even for the simplifications? I will try to do that actually if I have enough time. Okay, sometimes it is that you can see sometimes I'm running out of time. Even though I try very hard to not run out of time, but it's really difficult to make sure every time it's actually on time. Okay, and then sometimes I feel like I want to talk about something that's not directly relevant to your class, right? But sometimes I feel like it's actually even more meaningful to you guys because not all of you are chemistry major. Okay, so I think that may be something that could be useful for everybody. All right. Okay, so even though I cannot give you a promise, okay, I will try to do that. Okay, but do make sure that you put these things on the evaluation too. Okay, great, great. Is there a retest policy? You mean the makeup exam? Let's not retest things. Okay, so this is actually a question that you should actually always go back and check out your syllabus, right? So on the first day, I say, whatever is written on the syllabus is the way we're going to run this lecture. Okay, we have 4 sections, so I cannot just change the rule all by myself. Okay, it is not fair to all the other students in other sections. Okay, so if you have any question like this, you will actually most likely find the answer in the syllabus. Okay. If you found your question is actually not answered on the syllabus, then it's time you should actually come to me, then we should actually discuss. Okay, so next one. What grade is pacing on the exam? You're talking about a C. So you have 23 questions, right? So 60% of that, around 13 to 14 out of 23 is actually passing. Will there be a curve for the test grade? No. Okay, this is actually specifically said in the syllabus. Okay. Retest policy, I don't think so. My exam is tomorrow. Any advice? Good luck. Okay. Yes. Is it true the exam question get harder the longer you wait to take the test? No. Okay. So this is actually a good example that the student actually overcomplicate things. Okay. So the exam is set up this way. You have a big pool of questions. Okay. Remember in the very beginning, I tell everybody that 5 partners. Did I say that? I do, right? Okay. Why? It's because you want to actually probe the pool as much as you can. Okay, so if you see enough, you will see things actually start to show up repetitively. Okay, then you know you actually see every single question. Okay, so it's really just randomly pull the questions from the data bank. Okay, so what you need to do is actually make sure your data bank is actually big enough that you see everything. Okay, if you can do that, then you feel very confident when you walk into CASA. All right, so this is just a miss. Okay, so don't be fooled by this. Is today class review? Yeah, we're starting a new unit. Okay, chapter 13. We are coming. Okay. So this is not true, right? 1 point go to your grade overall the test 1. Overall. Okay, that 1 extra point was actually probably more than your 1 quiz. And all you need to do is actually put on your name, make some check, write something, and that's it. Okay, guarantee you got 1 point. Okay, minimum effort to actually earn the point. All right, so I guess that's actually all the questions we have today. Okay, any other questions? Okay, so we are entering chapter 13, 14, and 15, which is actually the most challenging chapters of this semester. If we survive, if we do well, we nail this course down. Okay, is that clear? Okay, so why this is actually a difficult 3 chapters? The main reason is that a lot of calculations, a lot. Okay, and then every single sections except mine, okay, except us, okay, we are going to do the ice table all the time, okay. From my personal opinion, that is actually the reason why everybody do so poorly for chapter 13, 14, and 15, because we are running out of time. Okay, so we are going to see for these 2 weeks, okay, we will go through this concept. We'll do the ice table for you only for 1 time. Okay, then I will tell you, once you do the ice table, okay, you actually always come to the same mathematical equation that you can solve. Okay, therefore, what I will ask everybody to do is actually to memorize the final equation to use. Okay, then All you need to do is really actually understand the questions, know what equation to use, then just do the calculation. Then suddenly you will realize you have so much time to finish all those questions easily and accurately. Okay, so that is actually a secret. That's actually the things we are going to practice for the remaining couple of weeks. All right, so since we are going to do the things slowly today, let's just go to our Hangout. So all these things has been uploaded to Teams. Okay, so by now I assume everybody know where to find all this content, right? Okay, and then recently the things that happen to me so often is that students send me a question. Okay, what I do is actually I copy the link of our recording, reply the chat and say, check this timestamp, you'll find the answer. Okay, these things keep happening. Okay, we actually went through many different type of questions. Okay, so if you do actually follow everything along, you should have that feeling too, right? So when you do your midterm or do your quiz, you should feel like, okay, we actually went through those concepts. Okay, so you want to do things actually continuously to happen for the rest of the semester, then you know you will be able to get whatever grade that you want. Okay. Oh, talking about that, I still want to show this to everybody. Okay, so just in case that you don't know where to find all the useful informations. Okay, so we always post the materials on our team site, right? See, I make a beautiful banner using my YouTube channel. Just in case that you don't see that, okay? Okay, and then all the things is actually here. Okay, so please actually download all these Hangouts. Okay, so we can actually go through all these challenging concepts smoothly for the midterm too. All right. Okay, now we can really go to this. Chapter 13 is all about acid and base. Okay, so what is acid? What is acid? Something is corrosive. Okay, that's actually how you observe, right? So that's actually a good definition based on the phenotype, based on the things that you observe, right? Scientifically, how do you actually define acid? Okay, I heard a very good term. Okay, pH. Okay, so pH is actually the term that we use to describe how acidic a substance is quantitatively. Okay, so pH is actually have a very specific mathematical definition. Okay, the P is actually stands for the natural log in the base of 10. Okay, that's what P means. H means the proton concentration. Okay, so what they tell us is that if you store a substance into water, if you generate a tons of proton, meaning you have very high concentration of proton, then the pH will be very small. Okay, so because you have this negative value. All right, we're going to talk about this probably on Thursday. Okay, what we're going to talk about today is actually some simple things. So what is acid? Okay, the definition of acid is this. Okay, if you throw something into water, okay, and it can actually produce H plus. Okay, it's generating H plus inside your water. Then that is actually an acid. Okay, so what is H plus? Proton or hydrogen? Proton. Okay, so what's the difference between proton and hydrogen? Why is this? H is hydrogen, right? If you look at periodic table, it's H, right? H plus is proton. Okay. The difference between the two is actually very clear, right? One is charged, the other one is not. Okay, so this one is charged, right? So that is actually a species that give you this acidic feeling. Okay, so it is a proton. It is not a hydrogen. Okay, that's actually the acid 101. Okay, the first thing that we need to actually know. Okay, there's actually different, these are two different species. Okay, H is hydrogen, H plus is proton. Okay, and this is actually the species that presented inside the water solution. Okay, so for CHEM1312, all the solution we're going to talk about is all aqueous solution. Okay, that means we did not consider the solution that's only have organic solvent. Okay, so all the things we are going to discuss for your midterm 2 or for your GenChem 2 is all about aqueous solution, meaning it's actually a water-based solution. Okay, and that is actually a very important concept because later on we're going to talk about salt. Okay, and we're going to talk about this KW. Okay, and all of things will based on the situation that if you have a water solution. Okay. The first concept that we are going to learn is to learn this thing so-called the conjugated acid and base. Okay. I'll give you example like this. Let's say you have something called Ha plus. You solve it into water. And then you generate H plus and A. Okay. Then we call Ha plus as a acid or base. Acid, right? Because generate H plus, right? So Ha plus is an acid. Okay. So this is our proton, right? So let's actually species got generated when you throw Ha plus into water. At the same time, you generate another species A, right? So we call this species A as a conjugated base of your Ha plus. Everybody's fine with this? Okay. We also call Ha plus as a conjugated acid of your A. Okay, so let me emphasize this again. Okay, this A is the conjugated base of Ha plus. Okay, and Ha plus is the conjugated base of A. All right, so we call A and Ha plus as a conjugated acid base pair. Okay, so let's actually the first thing we want to know. The main difference between the two is what? What's the difference between your Ha plus and then your A? Yes. Okay, so the difference is actually just a H plus, right? If today, okay, this is actually a question you're going to see in your homework. Okay, you say, write out the chemical formula for the conjugated acid of A Okay, so okay, write out the conjugated acid of A. Okay, so what do? You add H plus to the species. Okay, so the answer to this question will be just A plus your H plus, right? Therefore, you know you write out HA plus. Okay, everybody follow this? Okay, now write out the conjugated acid of Cl minus. What will be the answer? Yeah, so what is that? Good. HCl, right? Okay, so yeah. Right, the conjugated acid of CO3 2 minus. What will be the answer? Is that right? There you go. Okay. So the difference can only be one single H plus. Okay. But if I say this, then it will be this. Okay. So you're jumping 2 steps ahead, right? If you jump in 2 steps, then it is not the conjugated acid base pair. Okay, so this is actually a very, very important concept that you should know. All right. Any question for this concept? Okay, if you don't have questions, okay, I have another question for you. What is the conjugated base of your HCl? Yes, there you go, Cl minus. Okay, how about this? CO3 2 minus, right? And the conjugated base of this will be HCO3 minus. All right. So this is actually a very important concept that you must know. Okay, because once you have this concept, many things in the following discussion will be actually very straightforward. Yeah, either adding or remove one H plus. Okay, just one, not two, but one. Okay. So this is actually the first concept that we need to know. Okay. The other very important concept that you're going to encounter very often this week for your quiz is that identify the strengths of the acid and base. Okay. These are the 4 rules created by myself. Okay. You're not going to see this from your textbook. Okay, but this will make your life a lot easier. First concept is that both acid and base, they are weak. Okay, so you're going to see a question like this. I give you a bunch of chemicals and ask you, okay, is this a strong or weak acid, strong or weak base? Okay, so for most of the time, it should be either weak acid or weak base. Okay, so let's actually the first concept that you should know. Okay, second one, this is actually the first time we're going to use this periodic table. Okay. The rule of thumb is that if you see a species contain the element to the left of your periodic tables, it is basic. Okay. To the right, it will be acidic. of course, if you go to the extreme, those are the really strong acid and base. Okay, so things in center is weak. Okay. And then you should also know that if you are actually having the same elements, okay, in the same row, for example, if you go down, you also make things stronger. For example, if you go down, if you have a metal hydroxide, okay, then this CSOH will be actually a stronger base than your NaOH. Okay, so if you go down, you become stronger. If you go to the side, you will become stronger. Okay, so this is actually the rule number 2. All right, is that simple enough? Okay. Rule number 3. There are only 7 strong acids you need to memorize. Okay. If you say not less 7 strong acid, it's all weak acid. Okay. So what are these 7? HI, HBr, HCl4, HCl, HCl3, H2SO4, HNO3. How do you actually memorize these things? It actually all belongs to this column, okay, for the first couple ones. Okay, so all this, right? The first 1, 2, 3, 4, 5. The first 5 stronger acid. It actually all belongs to these 3 elements. Okay. Yes. Because it is not. Okay, so what do we mean by strong acid? How do we know this is actually a strong acid? Huh? Oh. Yes, that is the key. The hydrolysis 100%. Okay, that means actually if you throw a HI into water, it becomes H plus and I minus 100%. Okay, that means inside water, you actually don't have HI. All you have is actually HI plus and then the I minus. Okay, so it dissociates 100%. That's why we call it strong acid. Okay, so why HClO2 is not? Because when we store it in, it doesn't dissociate 100%. That's the answer to your question. Okay, so many of this definition is all obtained from experiments, right? So it all comes down to something that is going to be very simple. Okay, why do we call this strong acid but not lead 1? It's because we do the experiment, it is not, then it is not. Okay, the things I have here is how I could summarize all this observation. Then I tell you, okay, who are the one that can dissociate 100%, right? And then you need to know these 7 ones because the question you're going to encounter is always going to ask you, okay, what are the strong acids, what is not? But since you cannot do the experiment yourself, then knowing these 7 strong acids is actually going to be very helpful. All right. So I want to actually reference these orders to the things we just say, right? So we say if you go to the side or you go down to the table, it will be either more basic or more acidic, right? So if you compare this, HI and HBr, which one will be a stronger acid? HI, right? Because it's actually down at the bottom. Okay. And then HClO4 and HBr will be HBr. Okay. HCl, this is actually something that you need to. The reason I wrote in this order, meaning the strength is actually following this order. Okay, so you need to actually memorize the things in this specific order. So that if you want to compare the strengths of different strong acid, you know how to do it. Okay, so again, I want to emphasize all this hangout is after I polish, I read through the things for many, many years, right? This is actually the easiest way you can actually memorize all this information. Okay, so do memorize in this order. Okay, this two is actually something that you know. Okay, but there's actually no specific rules that you can actually know who is actually stronger, who is actually weaker. So the only thing you can do is actually just memorize it. Okay. So that's actually where you can find the species that's actually strong acid. Okay. Anything beside this is all weak. Okay. How about the strong base? Strong base is even simpler. These two columns. Okay, so if you see a chemical compound contains the element in these two columns, whether it is oxide or hydroxide, okay, either one is fine. Okay. Once you store this species into water, it dissociates 100% and generate the OH minus. Okay, so those will be the strong base and nothing else. Okay, so since you right now you know what are the 7 strong acids, you know what other species will be your strong base. Anything else will be weak acid or weak base. Okay, that is actually how you can solve this problem quickly and then accurately. Okay. Very last one is this. Okay, this is actually a special case for the acid called the oxalic acid. Okay, it will always have this form. It's going to show something like this: H, X, Y, O, Z. Okay, for example, HClO4, HClO3. Okay, so if you see a compound start with H and with oxygen, and it contains some other elements, we call it as a center atom. Okay, that is actually a typical form of the oxalic acid. Okay, so sometimes they will ask you to compare, okay, which one is actually stronger. Okay, the way you make the judgment is that by counting the difference, the total number of oxygen minus the total number of hydrogen. Okay, the one with a larger number will be actually a stronger oxalic acid. Okay, so why that is actually the case, we don't actually need to know, but the bottom line is actually once you have more oxygens, you're going to have more resonance structure, which can actually make the dissociation form more stable. Okay, so that's actually the fundamental reason for that. Okay, but for the CHEM1312, you actually don't need to know the reason. Okay, but you do need to know how to actually predict which one is actually stronger, which one is actually weaker. Okay, so those are the 4 rules that you will need to actually memorize for this week. Okay, for chapter 13. Yes. Yeah, so do you see this? HClO3, HClO4, and HClO2. You can also put in HClO. Okay, so which one will be the strongest one? Will be the HClO4, because the difference between number of oxygen and hydrogen, it is actually the greatest, right? So it's actually 3 to 1, 0. Yeah, so it is actually a very standard questions that you can actually make sense of. All right, any other questions? So why you cannot predict like that? First, they're actually different kind of acid. Right. So all those information, all this ranking is really coming from the experimental observation. Yeah. So there's actually, since they're actually not the same type of acid, there's actually no a single simple rules can tell you why, cannot tell you how to predict. Okay, so that's why I say, okay, remember that 7 specific strong acid in that specific order is essential for this chapter. Okay. Yes.
Does that have anything to do with like the oxygen breaking down and forming new water molecules of hydrogen?
No.
No.
It's all about the resonance structure. It's all about once you dissociate. Okay, once you dissociate, for example, once these things dissociate, you have what? You have H plus ClO4 minus, right? the structure of this actually looks like that. Okay, so this is actually especially stable because it's going to resonance with this. Okay, so you form you have all different kind of forms that can make this species exist. Okay, so later on, once you become a little bit older, okay, assuming you're going to take thermodynamics, okay, one thing we learn is called, okay, this is actually something related to some, I don't know whether you guys know this. Do you guys know what entropy is? Have you actually heard of that term? Okay, so typically people will say it's actually randomness, right? But the true meaning of entropy is that how many ways that you can actually dissipate your energy. Okay, the more you can actually dissipate your energy, that species will be more stable. Okay, so this is actually why resonance come into play. Okay, because right now there are actually multiple different forms can actually spread those energy. Therefore, this O minus species will become very stable, meaning that if we want to actually dissociate and present in the negative charge form. Okay, but those things is actually too much for you for CHEM1312. Okay, you don't need to actually know any of this. Okay, but that's actually the fundamental reason. Okay, so let's actually pretty much the first part that you should know. Okay, the second part that we want to talk about today is actually the acid-base property of salt. Okay, so salt sometimes we call it electrolyte. Okay, so in order to form a salt, what do you need to have? You need to have one K ion, one N ion. Okay, or those are the basic structure you're going to have. Okay, you have a compound. Once they dissociate, they become cation and anion. Okay. So if I give you a salt, okay, you throw it into water. One type of question I'm going to be asked is actually, can you predict the water solution or the salt solution is acidic, basic, or neutral? Okay, so what are the rules that you need to know to make a prediction? It's the things we want to discuss now. Okay. So the rule number one is that if you have a conjugated acid or base of a strong acid, okay, then that species will be neutral. Okay, so what do I mean? NaCl is actually one of the most famous salt, right? What you throw it into water, what do you get? Right, you have sodium plus and Cl minus. Right, how to know it's actually sodium plus? It's 1A group, right? So 1A group like to present in the +1 charge. 2A group like to present in the 2+ charge. Okay, no exception. Okay, these are the two very unique colors that you need to know for sure. Okay, so 1A group will actually dissociate into a 1+ charge. Okay. So these things is actually neutral, right? Since you know Na is going to become Na plus. Therefore, this has to be Cl1 minus, right? So that the net charge is actually balanced on 2N. Okay, the charge always need to be balanced. Okay, once you write out a chemical equation, it's actually something that's always true. Okay, so once you have this, okay, then you want to predict, okay, is this solution acidic, basic, or neutral? Okay, so then you want to actually look at this. Okay, let's look at this first. Cl minus. Okay. What is the conjugated acid or conjugated base of Cl minus? Okay, HCl is what? HCl is the conjugated acid of Cl minus, right? This HCl is a strong or weak acid? Strong acid, right? Therefore, the Cl minus is, look at our first rule. If you have conjugated acid or base of a strong acid or base, the species will be neutral. Okay, therefore you know this guy is neutral, right? Okay, so how about this? Na plus. What could be the conjugated acid or base of Na plus? Since it's actually Na plus, okay, if you want to find its conjugated acid, what do? You want to add in a proton, right? But it's not going to happen because positive charge, I'm already positive, okay? You want to add in another positive to me, we know positive they're actually going to repel each other, right? So it is extremely difficult to add a H plus to an Na plus. Okay, it's not going to happen, right? So you know you won't be able to write a conjugated acid of a positively charged species. Okay, then what do? You find a conjugated base, right? How do you actually write a conjugated base? Yeah, hydroxide is actually the key. Okay, okay, so to find out the conjugated base, you add in the OH minus. Okay, so if you add in OH minus to your Na plus, what do you get? Okay, so you got NaOH. So NaOH will be the conjugated base of your Na plus, right? So is NaOH a strong base? Yes or no? Yes, right? So that you know, this guy will be neutral as well. All right? So in this case, since your Ki ions and Ni ions both are neutral, therefore you're going to have a neutral solution. Okay, so this is actually rule number 1. Okay, so the acidity or basicity of a solution will be determined by the collective properties of your salt. Okay, so if your salt is actually a conjugated acid or base of a strong acid or base, then they will be neutral. So that's actually rule number 1. Is that clear? Okay. Rule number 2. Conjugated base of a weak acid will be basic. Okay. It sounds actually, I don't know how these things will actually make sense to you. Okay, and then if you have a conjugated acid of a weak base, then it will be acidic. Okay. Everybody found these two, the very last 2 sentences making sense? Not very clear, right? Okay, so that's why I want to actually revise this sentence a little bit. Okay. So if you see, I want to actually highlight the things I want you to look at. If you see a cation, okay, if the cation is conjugated base, it is a weak base, then lead cation will be actually a weak acid, okay? Cation will be acidic and ion will be basic. Okay, so these are the things I want to memorize. Cation, acidic, anion, basic. Okay. So with that being said, let's do some simple examples so you will see. Okay, let's say today you have a salt like this. NaCH3COO. Once it dissociates, what would you predict? What are the salts? Yeah, we see Na is actually our good friend, right? We always know Na will always like to become Na plus, right? Therefore, we know all the remaining things will be CH3COO minus. Okay, so this will be actually the dissociated form, right? Now we look at this. These are the two species ultimately will determine the acidity or basicity of your solution, right? Let's look at a cation, which potentially could be acidic, right? Na plus, you know, we need to actually looking for the conjugated base of that, right? What is the conjugated base of Na plus? NaOH. NaOH is a strong base, right? Meaning this guy will be neutral, right? So Na plus is the conjugated acid of a strong base. Okay, therefore it will be neutral. Okay. How about this? CH3COO minus, it is a anion, right? So you want to actually looking for is conjugated acid. Its conjugated acid will be CH3COOH. Is this species belong to the 7 strong acid? It doesn't, right? Therefore, we know this species must be a weak acid, right? So that means actually this is actually a conjugated base of a weak acid, right? So this will be actually basic. Okay, so since right now your cation is actually neutral, your anion is actually basic. Therefore, your overall solution will be basic. Okay, so this is actually how you make those judgments. Okay, so let me recap that concept. Okay, so once you see a salt, and you want to know once it dissociates into water, what are you going to have, right? You must have a cation, you must have an anion. Okay, so the cation can either be neutral or acidic. The anion will either be neutral or basic, right? So only when the conjugated acid and base, they are strong acid or strong base, then this anionic species will be neutral. Otherwise, your cation will be acidic. Your anion will be basic. Is that clear? Everybody follow this? Okay, so it is actually a very simple rules. Okay, if you know it, you know it, and then all the question will be actually very easy to solve. Okay, so to predict the acidity and basic of salt solution, the first step is actually write out the ionic equation. So we're going to have the cations and anions, right? So the cation can either be neutral or acidic. Okay, the same thing, your anion can either be neutral or basic. Okay, the only time they will be neutral is when they are conjugated acid and base, they are strong acid or base. Okay, all the others, then your cation will be acidic, your anion will be basic. Is that clear? All right, so with that being said, that's all the concepts that we need to know today. We'll just go through a few examples. Then we can actually call it a day. Okay, so this is actually a typical question you're going to see. Okay, it lists actually a couple of species over there. And ask you whether they're actually strong acid, strong base, weak acid, or weak base. Okay. The first one, NH3. This strong acid, weak acid, strong base, or weak base. Okay, so the reason I put it on the first question is because most of students have difficulty to answer for this specific species. Okay, what is NH3? Chemically, it looks like this. Okay, it has a lone pair on the top. Then you have 3 protons. Okay, so the nitrogen is actually a central atom. That is actually a species that can accepting proton. Okay, so we say if a species that can give out protons, that is called the acid, right? Nitrogen, it did not give out proton, it actually accept the proton. Therefore, this will be a base. Okay, since this is a base, now you can actually guess, okay, this is strong or weak. Do you see any elements in the first 2 columns? You don't, right? So this is not a strong base. This will be a weak base. Okay, so very easy to justify all this logic. Okay, so this is actually the things that confuse the student the most. So I want you to make sure that you know this 100%. Okay, if you have a nitrogen with 3 species attached to it, it is a weak base. Okay, so let me write this. It is actually a weak base. Okay, so this amine has a few variants. Okay, sometimes they will replace these protons with some alkyl chain. Okay, everybody know what alkyl chain is? A long carbon and hydrogen tails. Okay, so sometimes you will see, actually the second one is actually the example. CH3, CH2, CH2, NH2. Okay, so you need to have the ability to identify what this is. Okay, so what this is this. Okay, you see that CH3, CH2, CH2. Okay, that is so-called alkyl chain. Just a long chain with a series of carbon and hydrogen. Okay, it is not a hydrogen by itself, but it's just a bunch of carbon and hydrogen all together, and then attached to that nitrogen. Okay, but if you look at the structure, that is actually what it represents. Okay, so if you compare the two, they are actually very, very similar, right? Just in this case, what you have is actually 3 protons. In the other case, actually 2 protons with some alkyl chain. Okay, so that is actually also a weak base. Okay, because this is actually a lone pair that can accepting the protons. Okay, so this is also a weak base. Okay, so the variant of this is actually, I can actually replace these protons with lead as well. I can replace lead with lead as well. Okay, so in general, you can see okay, we call these things as R group typically. Okay, what it means is actually it's not just attaching to your proton, but it can actually attach to some alkyl chain. Okay, but no matter what it is, you always have these things that is actually your center atom. That is actually a species that give you the basicity. Okay, so you need to actually train your eye so that when you see the chemical formula, you know it is amine. Okay, amine is always a weak base. Okay, so these things, okay, will be very, very confusing with another species called this. NH4 plus. Okay, so what is the main difference between these two? Well, one extra Yes, one extra proton. Okay. Why is this? Weak acid or weak base? Weak acid. So the reason this is actually a base is because you have that lone pair, right? So right now you add in another proton, meaning they use this lone pair to catch that H plus. Okay, so let the whole thing become charged. Okay, so NH4 plus is a weak acid. Okay, so those are all the possible variants that you should actually remember. Okay, yes.
Could you explain that with the structure?
NH4 plus. Tetrahedral. Okay, so it's a lone pair to catch that protons. Okay, so you have this tetrahedral structure, and it become plus charged. Okay, then we say this cation is always a acid, right? Okay, so how about this guy? Acid, right? How do you know? Okay, yes, okay, but here I want to actually point out this is actually a standard structure of oxalic acid, right? You have H, you start from H, right? You have a center atom, in this case, is actually AS, right? And then you have O, right? So that's actually a very standard form of oxalic acid. Okay, so you know this is actually a weak acid. How do you know it's weak acid? Because it doesn't belong to the 7 strong acid. Okay, 7 strong acid. Only the 7 are strong acid. All the others weak. Okay, you must have these things registered to your mind. Okay, it is less simple. Don't overthink it. Okay. RBOH. Strong base, right? Because RB is what? 1A group, right? First column. So RBOH, strong base. Okay. HClO4. Strong acid, right? See how easy this is. Now you can actually answer all these questions by knowing the simple rules. Okay. Okay, now this is actually another type of question that you're going to encounter. Okay. Consider reaction shown below. Using your knowledge of reactive acid-base strengths and equilibrium, determine what you can say about the Kc for this reaction. Okay, when students actually see this question, they don't know what to do at all, right? So how to actually answer these questions? We need to actually use the concept you have learned from chapter 12, Kc. Okay, so when we talk about Kc, okay, when we write out the equilibrium constant K, right? You know it is actually a ratio between what? The product over reactant, right? It's actually your product over reactant. Okay. If Kc is larger than 1, meaning you have more product than your reactant. Everybody get this? Okay, if it's actually smaller than 1, it's actually you have more reactant than the product. Okay. Everybody fine with the things I just said? Okay, so those are the concepts you need to actually get used to it so you can see how to solve this. Okay, so how do you actually know the case is actually larger or smaller than 1? Okay, the first thing you do is actually in this type of question, you're going to always have 2 acids. Okay, and 1 on each side. Okay. What are the acids on the left-hand side? This is actually acid. Okay. What's the acid on the right-hand side? This is the acid on the right-hand side, right? And then you should also be able to see that this and this are what? Conjugated acid base, right? This is actually another conjugated acid base pair, right? So, with this being said, what I really want to tell you is that, okay, if H3 SbO3 is a stronger acid than H2TeO3. Okay, if this is actually a stronger acid than the other acid, okay, then the reaction will be pushed to the right-hand side, right? Because if you have stronger acid, means actually you are going to dissociate first, right? Therefore, if this is actually a strong acid, then you're going to have more product. Okay, then your Kc will be larger than 1. Okay. Of course, if it's actually the opposite, then your Kc will be smaller than 1. Okay, so that is actually a concept we are going to use here. Everybody follow this? Any questions?
We determined that that was our acids on each side because they were both neutral, right? Is that how we determined that? The ones that were highlighted?
So if you look at these type of questions, okay, you always find 2 conjugated acid-base pair. Okay. And then from there, you should be able to tell who is actually the acid, who is actually the base. Right. So apparently these 2 are the pair, right? And then we know going from here to here, you give out 1 proton. So that is actually a species, that is actually your acid. Okay, so that's actually the first step. Okay, so once you have this, the next thing you want to compare is actually, you want to compare the acidity strengths between these 2. H3SbO3 versus H2TeO3. Okay, so how do you know which one is actually a stronger acid? You want to actually go to your SbNTe. Okay. Which one is actually more acidic? Te, right? Because you know you are going toward the side of the table, right? Therefore, you know, where am I? Okay, so Te is actually a stronger acid, right? Therefore, you know that you should draw this. Then this should be smaller than 1. Okay, so let's actually how you solve this type of question. 3 actually trying to ask you whether you know the acid strength of the specific acid. Yes.
Where the O is 3 oxygen, 2 hydrogen.
So no. Why not? No. So you're talking about a rule of the oxalic acid, right? What is actually the things that you should have for the oxalic acid? The center atom has to be the same. Then you use the difference between the oxygen number and hydrogen number. That's actually when you apply the rule. Okay. Since right now the center atom are actually different, right? So using the periodic table rule to figure out who is actually the stronger one. Okay. So let's actually how you solve less specific questions. All right. So now this is actually the very last 3 questions we want to do today. Okay. So predict the NaNO3 acidic, basic, or neutral. So step number 1 is actually to write out the ionic species, right? So what you're going to have is Na plus and then NO3 minus. Okay, so Na plus is acidic or neutral? This one is acidic or neutral? Neutral, right? Because its conjugated base is NaOH, which is actually a strong base. Therefore, this is actually neutral, right? How about your NO3 minus? Its conjugated acid will be HNO3, right? Is HNO3 one of the 7 strong acid? Yes, it is one of the 7 strong acid, right? Therefore, this will be neutral as well, right? Since both your Ki and En, they are neutral, therefore your solution will be neutral. Okay, that's how you actually approach this type of question. All right. Second questions. NaCH3COO. Okay, so you want to write down this, right? So you're going to have Na plus CH3COO minus. Right? In this case, okay, your Na plus is actually acidic or neutral. Neutral, right? Because it's conjugated base. NaOH is a strong base. Therefore, this one will be neutral, right? How about your CH3COO minus? Is it base or neutral? Base, right? Because its conjugate acid is CH3COOH, which doesn't belong to the 7-strong acid, right? So this will be basic, right? So since you have one neutral, one basic, your overall solution will be basic. All right. Okay, very last one. C2H5NH3Br. Is that acidic, basic, or neutral? So you want to write out its ionic form, right? What is your Ki ion? C2H5. And then? NH3. And then? Where's your charge? Br. Okay, and then? Is this the species you're going to write? Is this actually right ionic species? This is actually part that you're confused, right? Okay, so remember this. I guess right now, everybody's actually fine with like 1A group. For this column, you know it has to be all 1 plus, right? For this one will be 2 plus. For this one will be 1 minus. Okay, so this is actually always 1 minus, okay? Here, 2 minus. Okay, remember this 4 column will make your life a lot easier. Okay, so with that being said, let's go back to this. Can you actually write out Br minus quickly with those concepts? Okay, so once you know Br can only present in the minus, then all the other species will carry 1 plus. And therefore, you know this is a species that you have. Okay. Everybody follow the things so far? Okay. Let's start from the simple one. Okay, Br minus. Is this going to be basic or neutral? Neutral, right? Because its conjugated acid is HBr, which is a strong acid. So this will be neutral, right? How about this? What will be the conjugated base of this guy? C2H5 and H2. Do you see that? You minus H plus, right? So you minus H plus, you minus a proton. Okay, so you go from this to its conjugated base, right? Okay, so what is this? Is this a SO base? This guy. Is this a SO base? You guys not so sure, huh? Let me give you some memory. We went through these questions, right? Just a couple minutes ago. You can see how easy student can actually figure out. Okay, this is actually a species that every student has problems. So you really want to train your eye to see this. Okay. You need to do actually a couple of practice to make sure you can actually register all this knowledge. Okay, so this guy apparently is actually a weak base. Okay, so this actually your conjugated acid, right? Therefore, this one will be actually a weak acid. It is acidic. Okay, so you have acidic cation, neutral anion. Therefore, you have acidic solution. All right. Yes. I cannot really hear you. Sorry. Can you speak a little bit louder? Okay, so that's actually a very good question. Okay, so if your cation is actually acidic, your anion is basic. Okay, then what will make the solution be? That's your question, right? Okay. How would you actually think about this question? It's actually a very interesting question. It's a good question. Okay, but will it happen? Okay, so the salt we are talking about right now is so-called the soluble salt. Okay, we're going to talk about the insoluble salt in the future. Okay, so the one we are going to work with is always the soluble salt. Okay, meaning it's going to dissociate 100%. Okay, so to have a soluble salt, 99% of the time, it must be a combination of a strong acid or strong base with a weak acid or weak base. Okay, so the things you say will not show up here. Okay, I hope that actually answer your question. All right, any other questions? If not, we will conclude today's lecture. Okay, good luck with your exam. You haven't done it. Okay.